Bah humbug.
Here we are, bah humbug. Back to Grumpy Science with Mark Tommerdahl and Bob Dennis.
And we've gotten a few more questions and comments on heart rate variability that we were talking about before. So we clear up a few things. First of all, what is heart rate variability? Because when people ask, what does heart rate have to do with brain health? That's a good question, because if your heart's not pumping, your brain ain't working. But because, and what we mentioned last time, we were trying to get across the point that because a lot of people have smartwatches that measure HRV, and because the makers of the smartwatches that collect HRV are pushing it to do everything from, making your smartwatch cook bananas versus making ice cream to checking your brain health with heart rate variability, we just have to sort of step in and say, well, let's kind of like talk about what exactly is the relationship between brain health and heart rate variability. First of all, Bob, you want to explain what a second derivative is?
Well, no, I'm going to explain to Mark. Smartphones can do everything. I have a hammer app, and I can prove it. I can hammer nails, right? So, Mark, you're just too grumpy.
Okay.
You can do everything that you want to do with a smartphone, and you can do it perfectly well.
That's
so don't
true.
Listen to a word that he's saying.
I stand corrected. So
don't listen to a word he's saying.
The nail didn't go in very well.
That's right. I hammered the nail all the way down onto the floor. So do I want to explain a second derivative? Yes, I do, actually. Everybody knows what position is, I think, like position of a car. So what's the speed of a car? It's how fast that car is moving. So that's first time derivative of position, would be velocity. Mm-hmm. So its position might be a mile down the road, right? Its velocity might be 50 miles an hour. That means in 1 hour, it's going to go 50 miles.
I really wish you used 60 miles an hour, because that's a mile per minute.
But I'm old and slow and cautious, and I always get out of my car and look around at every intersection because I don't want to run over any rabbits or anything. That's just me. Okay. But whatever speed it is, that tells you X miles per hour, kilometers per second, whatever it is, that tells you how the position changes with respect to time. That's a first time derivative. That's velocity. So you've got position. The first time derivative of position is velocity. The second time derivative of position is acceleration. That is how fast the first time derivative is changing. So acceleration is how fast velocity is changing. Velocity is how fast position is changing. We have specific words for that because position is so commonly used and we experience it physically. We talk about, distance, velocity, and acceleration. But for a lot of things in the physical world, we don't have a specific word for it. So we get all mathy about it. We talk about like the first and second time derivative. Is that the answer you wanted?
Yeah, sort of. I say, now,
how does that relate?
Right. Now, how does that relate to heart rate?
To heart rate.
Heart rate. So heart rate typically bump, 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 bump. Guess what it does in old people sometimes? Or bump, 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 bump.
Yeah, mine.
Pick the tune of your choice. And
right. Mine normally plays rousing marches, but that's just
yeah. Mine goes to the tune of William Tell's Overture. So
there you go.
So anyway, and when you're what you want is a nice steady heartbeat, and it will accelerate when you start running or running up the stairs or chasing after kids or whatever.
Heart rate changes on the basis of a number of things. We talked a couple videos ago, we talked about how they measured because of shock and stress of the Apollo pilot and commander, actually.
And that might have been what led to the confusion.
Right.
We were talking about how heart rate changed.
That is under stress, but also heart rate changes because of physiologic demand, changes in physiologic demand, oxygen. But
sometimes it changes for no reason. No
Sometimes
apparent reason. So what people do is they get monitored for a long period of time, and they go bump, 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 bump. And if you have a whole lot of those, you might be getting set up for a heart attack. Now, we're not heart doctors, and we make no claims to understanding any of this, but what I'm just telling you, and basically all we've done is teach physiology students for about 30 years.
About 30, yeah.
But basically, when people get in those conditions where they have a lot of bursts of activity in their heart for no apparent reason, they say, we need to make that heart rate steady, and they give people medications for that. And one of the medications is a beta blocker.
Very potent medications. That's right. So what they're looking at is make the heart rate steady. And they're not really looking at side effects. They're sort of like, I don't want this person to have a heart attack, so I'm going to impose chemical controls that cause the heart rate to be steady. And how is it that beta blockers work? Do we know?
It's sort of like putting a governor on your carburetor.
Right, but it works cortically, doesn't it? Partly?
No.
No, it does not. It doesn't
Works
work
on
on part
the
of the
pacemaker.
It works just on the pacemaker of the heart, which is
At least I think
the
it does.
sinoatrial node, I guess.
Okay,
right?
so when beta blockers first started using, a lot of MDs declared, we won't point too many fingers.
Oh, that's right.
A lot
this
of
is why I
it
was
that
wrong.
did not cross
That's
the blood-brain barrier. And
So-
because its effect is on the heart. So, you have pacemaker cells that are deciding when your heart should
right.
beat, because
Yeah, I
this is
forgot
part
that.
of the autonomic nervous system. And if autonomic sounds like automatic, you don't really think about breathing and your heart beating and things like that. So the heart is part of the autonomic nervous system, which is the peripheral system and a little sliver of the brain.
Right.
Okay.
So there is some kind of brain involvement there, but it's not really, it's not even in the cortex, is it? It's
hypothalamus.
It's hypothalamus, right?
But you can everything's connected in the brain. Okay. So, and we know that. And so what people have found is that heart rate variability, like how much your heart changes and changes rate, that does get influenced in some conditions. Like if you whack somebody on the head with a baseball bat, your heart rate variability sometimes changes.
Doing something to the brain can have some sometimes not predictable effect on heart rate. So just to say, oh, everything's connected, and so measuring HRV tells you something about the brain, it kind of doesn't. That's like saying, well, I'm going to describe my house, 12. What am I talking about? 12 bedrooms, 12 windows, 12 steps up to the house. So it's like, like a single number like HRV can't possibly describe everything that's wrong or right with your heart and your brain. It's very nonspecific.
Yeah, sort of look at it this way, is that the CNS, or central nervous system, is what we're really interested in evaluating. That's made up of the brain and the spinal cord. Autonomic nervous system is a lot of peripheral stuff and peripheral nerves and a little sliver of hypothalamus and a couple of other things. But, it does a good job of controlling things and making them steady. Now, but if you want to use HRV as an indicator of what's going on in the brain, we can probably come up with a few examples where things are very different.
Yeah, like what's going on in your brain is totally different from what's going on in your body, and your HRV is reflecting what's going on elsewhere in the body.
Right. So one thing we had mentioned is, we just mentioned that, you give somebody beta blockers or heart medications, and that improves their performance of their heart. My parents' doctor, who's like 120 years old, he kept prescribing them beta blockers, and but it did not help their cognitive performance. In fact, it declined
over time.
Quite a bit.
It really has a tremendously negative effect on cognitive performance and just general brain performance too.
Right, and you talk to any healthcare worker in the field, and they'll anecdotally, and these are like people in assisted living facilities
for 5 or 10 years.
Oh, well, we took them off heart medications. All of a sudden, we had a good conversation with them.
Yeah, I've heard this all the time. It's like, yeah, we took them off their heart meds, and all of a sudden they started to seem really lucid, and they could remember things and everything. So you got this thing that supposedly didn't cross the blood-brain barrier, was having really profound long-term effects on a person's cognition.
Yeah.
And it's not positive, whereas the beta blocker effects on the heart can actually be very positive.
On the heart.
Yeah, on the heart.
So,
just at the heart, man, you can have a person where the beta blockers have really undermined their ability to think and interact with people effectively, but their heart, man, thumping away, boom, boom.
Yeah,
regular
as
a Swiss rail system, thump, thump, thump.
And I'm sure everybody's known somebody whose heart was beating just fine, but their mind was not keeping up with the train.
Right.
So, but don't believe, but you should always go to data, and I'm always happy to go to data. And so, over a decade ago, we did a little study, and we said, let's take a look, and we had found that some of the brain gauge measures, particular accuracy and plasticity, and we talked about neuroadaptation and plasticity before, those remain constant up to age 65. Or that was a study we did. We looked at people from 18 to 65. All the healthy controls looked the same. for a couple of the measures. And that was pretty solid, pretty good indicator that if we got a healthy control and studied the healthy control, then their values look pretty dang good. So we said, well, what happens over the age of 65? So we recruited some people from an exercise class in a senior center. And so after they'd done their little workout or whatever, they came by and we tested them. And now their results, you think their results look like age 18 to 65, Bob?
For their heart?
Well, no, I'm saying we tested their brain. Well, their results were all over the place.
Yeah.
And so then what we did was, well, let's do a little cluster analysis because we have some other data on these people, and their data actually clustered. You want to explain what a cluster is?
The way I think of a cluster is not family friendly, so I'm going to let you explain it.
Okay, so you might get two data points on a graph, and you get some over here clustering in one place and some over here. We had data points that were clustering around healthy, normal, and we had data points that were pretty bad. So, whenever we do a study, we try to be thorough. And so I took a medication list on each and every subject in that study.
Oh, yes, I remember you told me about that.
And then we looked at all the healthy people that had clustered high and they were healthy and had great brain health scores. Turned out
drug-free.
They were
more or less.
They were heart medication free.
Heart medication free.
All the others, the ones that had not, they were all on beta blockers.
Ah.
So I was like, well, that makes sense.
Mm-hmm.
That's about the time I asked my dad. I said, "Oh, you're not on. Hopefully, you're not on any beta blockers. They do terrible things to you." You go, I've been on for 10 years.
I've been on for 10 years.
Okay,
oops. Right.
Oops.
That explains a lot.
Yeah, a year later, he didn't know my name, but
right.
So that's the way it goes.
So, if I may summarize, it seems to me that this is beta blockers are one case where we can show that a drug can have a particularly good, healthful effect on one organ, as far as we know, the heart, and it can have a particularly negative effect on a different organ, the brain.
Yeah.
And that if you're measuring HRV, it'll tell you everything's great because it's measuring only the variability of your heart rate, and it will tell you nothing about the damage that you're doing to your cognitive abilities. So
there's some other examples of this too. And let's get off this topic of HRV and let's just open it up to the broad spectrum of perception of something that a drug can do can make you feel good. Like a lot of people are describing amphetamines to people with concussion because it makes them feel better and they can return to play sooner. But the damage is still there, and that's probably not good. That's
a really pernicious thing where they give you something to make you feel better so that you can go out and play again without actually knowing that you're out of the woods as far as damage to your brain. So that's a really, really bad practice.
Yeah, and sort of same
but
thing
people
with
feel
pain.
better. They're like, yeah, I feel great now. I'm ready to go out and play again. But they don't know. They haven't measured their brain function. So I think the way to sort of summarize up everything that we're saying here is, if you want to know how your brain is functioning, you need to measure your brain function, right? Some other surrogate or proxy measure like HRV is not going to tell you what you need to know. Whether you feel pretty good, hey, that's great, I'm all for it. That doesn't tell you if your brain's actually functioning well. Whether your heart is thumping along like the Swiss rail system, to the second, boom, 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 boom. That's great for your heart, but that doesn't tell you really whether or not your brain is functioning well. So the questions that we've been getting, gee whiz, why do I have to spend money on something else? Can't I just use my smartphone or smartwatch to measure HRV to monitor my brain function? I think, speaking scientifically, the answer is a resounding, robust no. You cannot do that. Well, you can. It's just it will not tell you what
we're not saying HRV is not a good measure.
No, it's a great measure for measuring the variability.
The autonomic nervous system.
It's a great measure of the autonomic nervous system, and in particular, it's a great measure of heart rate variability.
Right.
I mean, if you want to know your heart rate variability, the thing to measure is your heart rate variability, right? That's what you want to measure. If you want to know your temperature, you don't measure your height or your weight. You measure your temperature.
We're actually very interested in studying autonomic nervous system.
Oh, it's very
like
interesting.
This,
yeah, absolutely.
And looking at relationship between autonomic nervous system and central nervous system, because there are some important changes that happen in terms of those two things when people start entering into the degenerative state. Mm-hmm. And so that's the kind of thing that I'm very interested in looking at.
All of this stuff's very interesting, but I guess the point that Mark and I are making is that if you're going to measure something, first of all, make sure if you want to know something about your health, make sure you're measuring the right thing. HRV doesn't tell you about brain health, as far as I know, unless there's something really wrong with your brain and it's impacting the autonomic nervous system in a negative way. But that's a separate thing that's non-specific. So if you want to know something about your health, you have to measure the right thing, and then when you measure it, you have to measure it accurately. And smartphones and smartwatches are really good for certain things, like telling time, maybe talking to a GPS telling you where you are on the surface of the earth. It's good for those kinds of things. But it's not good for the kinds of tests you need to take to test your cognitive function, like reaction time and these other things that the brain gauge does. So once again, can you do these other things? Sure, you can do whatever you want to do to measure whatever you want to measure. But if you want an accurate and meaningful number that tells you something about the thing you want to know about, measure your brain if you want to know about your brain. Measure your feet if you want to know about your feet, or your heart if you want to know about your heart. And that's what we're saying.
Yep. And that's the thing. The other thing to point out, brain gauge does measure multiple functions of brain function.
Well, it's highly specific to the function.
And
right?
HRV
it's general.
Does get
Maybe
worse
a little
if
bit.
some aspect of brain function gets worse.
Yeah, and that's
another way to think of it.
But HRV is also highly non-specific. It could become something completely unrelated to brain function could drive your HRV really high or really low.
Yep.
Anything else?
I think it's probably good enough.
Okay.
All right.
There we go. Talk to you later.